Welcome to this video on some content that is new to the SAIC Style Guide in version 2.0, our bonus model planning example content. Our SAIC Style Guide is in fact a model-based style guide. It's built in Cameo itself. And there are many reasons why we did this. The primary one, the driving factor behind it, is to reduce ambiguity in the style. When you have the style in a style guide in a model itself, then the modelers who really need to follow the detailed technical implementation of that style can interrogate the model itself to really understand things that are very difficult to explain in words. They can open up specification windows, navigate between diagrams, and the containment tree and the structure tree, and really understand what is going on behind the style. In addition, because the style is in the model itself and all the examples that illustrate the style are in the model, we can run the validation suite against our style guide and determine that we have both correctly built the rules themselves and that our illustrations are all accurate and do conform to the rules that are in the configured suite. And in fact, we created several custom rules that we added for when you're modeling a style guide instead of a system architecture model, which is what our general style applies to. Because the style guide is in a model, we also can illustrate the interrelationship of the rules to each other and to other things. For example, currently, and this is in a previous release, all of our style rules are traced to steps in our simple process that is also captured in the style guide. Because both are modeled together, we could do the traceability very easily, analyze it, put rules in place to make sure that that traceability is complete. And now that we have that traceability in place, it's been very helpful when we are training people to use the simple process, or we tell people when they're using the simple process on their own, they can see for any given step what are the style rules that are relevant, open those diagrams, and have a full picture of what any particular part of the process means in terms of the technical details of implementation in the model. In addition, if you look at the process, the overarching process, and you decide certain parts of that process are not relevant for your particular program, you can more easily tailor the style rules to fit your actual application of the process, leveraging the traceability between the two of them. And in fact, we thought that we could take that a step further, because how indeed do you know what steps in the process are relevant to your particular program? So what we decided to do is a little example of how you can put a content plan, a very simple content plan, into a model, trace it to the process, and therefore use that to tailor your style and your process for your particular program, leveraging all the goodness of having a style guide in a model. The new content can be found in the SAIC DE style guide at the top level of the containment tree in the 5th of the content diagrams, 5 bonus model content planning. This diagram shows all the tables and the matrices and diagrams that we created in order to give you this model content planning example. Please note that this example is not a new part of the style. You don't have to do this content planning in order to use the SAIC style or the validation suite or any of the other tools that are in this package. It's just an example of something that you can do with the style guide since it is in a model. And we're hoping that it will also help you understand why we include the content that we do include in both our process and our style guide, because we're going to show you how both of those things can align to a variety of digital engineering goals that people might have in mind when they are building a model. So our planning process has 3 layers into it. You can use other layers, but in this example, we include a top level of kind of high-level use cases or end states that we want to achieve for our program, a middle level of very detailed kinds of goals that we want to achieve with our digital engineering enterprise, and then at the lower level, the detailed content that is required in order to support those goals. Because we derive the highest level goals actually from the more detailed goals in this particular example, I'm going to start with the middle layer, the modeling goals. So this table shows a list of typical goals that people want to support when they're doing digital engineering in general and model-based engineering in specific. So, for example, we might want to support milestone reviews with content from our model, such as a CDR or a TRR. We also might want to support deliverables, such as an external or an internal ICD, either by generating documents from the model, in a little bit of irony, or delivering the model itself in replacement of that content. In addition to these kinds of deliverables and milestones that we've represented here as a list of artifacts in there, we've talked to many programs about the kinds of goals that they have when they are wanting to get into the digital engineering space or build a system architecture model. And so we started to list some other types of representative goals. Obviously, this list isn't exhaustive, and some of these goals might be completely irrelevant to your program. That's the point. You should tailor this list of goals to what is actually true, both adding and deleting goals in whatever method that you use to solicit the goals of a particular program. You should express these in the terms that the stakeholder understands them, add documentation as needed, and do whatever level of detail really makes sense to the program. So once you have the list of goals, you'll notice that several other columns are populating here. And the most interesting one is, what content do I need in order to support the goal? For example, if I wanted to do a model-based RFP, I would need many of the elements of my logical architecture, particularly at the higher levels. I would need pedigree to any kind of source documents that establish the RFP, requirement satisfaction relationships between the logical architecture and any requirements that I write to support the RFP based on that architecture, our use cases, the actual system requirements, and then realization relationships that you as a representative of the acquirer would create from a logical architecture to any physical architecture that is proposed as a solution. So where is this content defined and how did we get it to show up in this column? I'll show you that in a second. Just let's hop over to this next column over here. The next thing is, what processes supported the creating of this content? And that is also here. I need many different kinds of activities in my architecture modeling process in order to create the content that is necessary to support a model-based RFP. So let's take a look at the traceability that's going on behind this, and then let's dive into the content column here by looking at another table. So I'm going to go back to our content diagram. There are many matrices in here, and they're really the heart of this planning example that we have here. So one of the things that we did in the background is, for every step that is in our process, we came up with a list of potential artifacts that could be created from that process, and we baked in the traceability for you here. So this matrix establishes the relationship between the process that already existed in the style guide and a starter content list. Note that we did have to make some assumptions when we did this. We assumed, for example, 3 layers of decomposition: system, subsystem, and component, in both the logical and the physical architecture. That is something that you would have to tailor for your own program depending on the levels of decomposition that you are using in your own program. We also then provided traceability between the content items and the goals themselves. And this one has our goals that you saw in our previous table down the left-hand side and our content items across the top. And this is where you need some judgment. What types of modeling content aligns with the kinds of goal that you have? And if the modeling content isn't sufficient to support that goal, what else might you need? So let's talk a little bit more about the content part of it. Our content plan, to me, is one of the most interesting parts of this little example that we have here. So here we have that list of artifacts that you were seeing in those matrices before and that you saw reflected in a different column in the goals table. Again, we have pre-aligned these content items, the ones that were related to the process steps for you. But again, notice that these are broken down into levels of decomposition. What's really great about this is that you can see for any given content item that you are creating in the model, what are the things that you are actually accomplishing for your program? What's the value that you're going to get out of that? How important is that, to your program? In addition, if you find a content item, maybe from our pre-generated association of our full process and the content items that it creates over here that supports none of your specific goals, perhaps that content item isn't required. And depending on whether none of the content items for a particular step are necessary, that process might not be relevant to you as well. So this allows you to determine the relevance and the value of the different content in the system architecture modeling process. In addition to that, not every goal that people have for model-based systems engineering or for digital engineering in general can be supported strictly by a system architecture model. You might need additional model content, such as test planning content, maybe test configurations. If you want to establish a higher level enterprise architecture and show how different systems are relevant to that, you might need to add a mission model there. You might also need to do traceability in a digital thread to other types of tools in order to support other goals. If I wanted to, relate risk management to model-based systems engineering, I would either need to add traceability to some sort of a risk management tool or apply or create some sort of a risk profile in my modeling tool itself. Again, the specific types of content here would be specific to the program, and you would want to use your digital engineering SMEs in this part of the process where we are aligning content to the goals and determining what exactly is sufficient and what is the best home for that content in here. So that's created two of our 3 layers here. But some feedback that we got when using this sort of a example process with a couple of programs was that 55 or so specific goals is a little bit difficult sometimes to brief at a higher level management meeting when you want to talk about what's the overall vision that you have for your program. So we created one higher level view, which we call our digital engineering use cases or end states. And this describes kind of a collection of lower level goals that we kind of rolled up into one higher level end state here and put some nice descriptive text in here that you could use when pitching this to management or to explaining your accomplishments on your program. So this sort of thing is much more valuable perhaps to briefing your plan than to developing your plan. The goals and the content is an important part of developing the plan. But it does give you kind of a high-level picture you can put on a slide and some great words that you can say to support buy-in, for your plan. Once you kind of have those basic pieces in place, process to content, content to goals, goals to use cases, and there's another matrix that supports that traceability in the model as well. Now we can start to layer in some metadata to help us more with our planning if that's of use to us. For example, in this content plan, we didn't t-shirt size any of the basic modeling content. T-shirt sizing here would be just sort of a relative indicator of cost, complexity, time. It's often used in agile engineering here because our decision was we're going to build a whole system architecture model because that was just part of our default. It was already part of our plan. But if we wanted to add in any of this, other work, how complex is it? You could put that here. You could go in and you could go with your stakeholders to do a prioritization exercise. If you know how complex something is and how important it is, then that can help you develop a more detailed roadmap of when you want to include additional content beyond the model in here. You can include rationales for the sizing, that are in there. And if you do end up adding this content, you could expand that simple process into other processes, which you could model and trace to this content list as well, and include that in your program's planning documents. In addition to that, we decided to add one more little bonus, 2 more little bonuses, I'm sorry, the tooling for this. So most of our system architecture content requires, your systems modeling tool and a requirements management tool of some kind. And you can see, we've suggested named tools in this particular plan. Obviously, there's many options that are here, and we're not representing them all. And in each case, we also represented beyond that modeling and requirements tool that are sort of the key key parts of the system architecture process. Other tools that you might need, like a PLM tool or a web-based dashboard tool, risk management tools, DSM tools, and suggested named tool options for that. And once you do that, you can you complete all of that. You can create kind of a high-level picture of what are all of the tools that you would need in your digital engineering enterprise in order to support the goals of that particular program. And obviously from here, if you wanted to, you could drill down and you could start doing IBDs and all kinds of other detail. For high-level planning, that's really not necessary. And then the final thing that we did is that if you have a model content plan and you have a model where you could do traceability between the actual model that is being built based off of this plan and this plan, which I wouldn't recommend importing this whole plan into your system architecture model. You might not want to import your system architecture model into this plan. This should generally be done in a federated manner where you have a third traceability model that uses both your actual models that you were building and your planning model. But once you have that in place, you can do traceability and you can say, these are the actual artifacts that I created for this content item, and that's whenever I'm supporting one of these goals, those are the content items that I need. So you can use this for statusing and for helping people understand if they're a stakeholder for one of these particular goals, what they need to look at in the models in order to see what was created in support of that goal. So that's all we have for this little high-level example. We hope that you find it useful and find other uses. We'd be really interested to hear of how a model-based style guide and model-based processes can be leveraged in order to help you achieve your digital engineering goals. Thank you very much.